Okay, so what does all this mean? Second derivative, how does it actually look when we graph it? So I've plotted on here on Desmos this function y equals x cubed plus 3x squared. And you can see that there's some critical points happening here. We've got a maximum here, we've got a minimum here. We've kind of got some unusual sort of shapes, a bit of an S-bend going on. I'm just going to plot the first derivative. So we've noted already that the first derivative represents the slope. So when the slope is 0 at these points here, this little maximum, top of the hill, minimum, bottom of the hill, the derivative there is 0. The slope is 0. If we were to put a tangent there, the tangent would be horizontal. So the horizontal line there would represent a slope of 0, which means that this function, which represents the slope of the red function, this is the derivative, when it gets to minus 2 is 0. Hence, the slope being 0. And when we get back to 0 here, it's 0 again. So that's the first derivative. What about the second derivative? Let's turn the first derivative off and put the second derivative on. Okay, so we see there that it's literally just a straight line. Okay, and in this case I think it's 6x plus 6. So what's this telling us? Well, if we notice where the second derivative goes through 0, we see that it's at minus 1. And if we look at the original function to see what's happening at minus 1, which is here, what can we notice? What we notice is that that's actually where the shape changes. On the left of this point, it's concave, and on the right of this point, it's convex. Okay, other language for that is sometimes called concave down and concave up. I like to use convex. So what it's really showing is when it's 0, it means that it's a change in shape from concave to convex or convex to concave. It's also showing us that when it's negative, so when the second derivative is less than 0, it's always going to be concave. Okay, it's always getting pulled downwards, if you like. It's almost like it's got gravity pulling a ball down onwards. The force is down. Once it reaches this point here, the second derivative becomes positive, and the force on it, if you think of it like that, is actually pulling it upwards. It's almost like you chuck a ball up and then it jumps into one of those huge big fans where you can go skydiving, and it starts pushing it upwards. So the force now is directed upwards. So within that little, infinitesimal little point, there's a change in shape. And that's what the second derivative is about. Understanding information about the shape.